I sort of feel slightly shell-shocked to be here because I've really spent the last 2 years leaving the nice, cosseted world of the cultivated garden and both physically and metaphorically have wandered off into the wilderness. So it's a sort of shock to see you all and to realize that I have to come back into the real world. But I've spent the last 2 years on bogs all over the UK. Yeah, no, I know, it's a good joke. Because I wanted to really get to know them. I am deeply frustrated that we are still using peat in our industry. And I am getting long in the tooth. I've actually been doing this for 27 years, and we're still not far enough along on the peat-free journey. And I wondered whether it was because we just didn't really understand what peat was. And if we could have a relationship with peat, perhaps we would change how we feel about it. And so I went to go and find the peat. Now, you can find peat all over the world. You can find it in tropical rainforests. There's a large part of the Congo Basin. You can find it with peat. You can find it in Australia. You can, of course, find it all across the northern hemisphere. Lots of the boreal forests sit on peat. And then you can find it all over Europe as well. Most of our peat, it makes up 13% of the UK landmass. And most of it is to the north and to the west, because the wetter you get, the more likely you are to have peat. There are 3 different types, 3 sort of broad classification for bogs in the UK. So we have 2 different types of peat in the UK. We have fens and we have bogs. The simple distinction between these 2 is bogs are acid and fens are alkali. Most of the peat that we mill for horticulture come from bogs. And actually I'm shamelessly just a bog person more than I am a fen person. So off I went to the bogs. So here are our 3 broad categories for bogs in the UK. There are blanket bogs. Like the name suggests, a blanket bog blankets the landscape. And it is a long, continuous seam of peat that tends to grow in very high places, so up on mountains with a high rainfall. So that's the major source of our bog, is blanket. This is the flow country. This is the most pristine, the largest blanket bog in Europe. Fantastic, in the northeast corner of Scotland. If you've never been, go. Here's another bit, because isn't it beautiful? It's kind of hard. Bogs are fantastic. You will be in love with bogs by the end of this talk, but you won't be in love with my pictures, because it's super hard to sell bogs on pictures. This is the other type of bog. This is a raised bog. And a raised bog grows like a dome in the landscape, and it's its own discrete, generally circular space with a dome. So the peat is rising up off the landscape. And then the third one, I promised my wife I would never show this video. But this is, do I just press play and does it go again? I'm just going to endlessly, oh no. Anyway, this is the funniest of all bogs. This is a quaking bog. And a quaking bog is called a quaking bog because if you jump up and down on it, it quakes. And that's because it is sitting on a 10,000-year-old lake underneath it. So when the glaciers retreated and the waters melted, in depressions in the landscape, little lakes would appear, and if the conditions were right, the bog would grow as a sort of thin layer over it, and so underneath is still the water. So when you're jumping up and down, you're literally jumping up and down on water. And quaking bogs are fantastic. This is a very small one just outside Builth Wells in mid-Wales, and if you get a chance to go to one, they are cute and brilliant little spaces. All of our bogs are known as androgynous. It's a really wonderful word. It means born of the clouds. So the bogs in the UK are only increasing in peat because they are rain-fed. So all their waters come from the sky. This means that they are hugely nutrient poor. There are lots of things in rain. There's nitrogen and phosphorus, and there are all sorts of bacteria and spores and all sorts of things, but there's not so much to make these environments highly nutritious. And so one of the things that defines a bog is it's very acidic, very nutrient poor, and is kept alive by rainwater. Now, when we look at peat in horticulture, we often look at this slightly bland, sterile, porous, very uniform product. It looks essentially a bit like it's dead. It is not doing much unless you add other things to it. And so you sort of assume that peat is a semi-dead thing. But the truth is, a peatland that is allowed sovereignty over its waters and can govern its own ways is an entirely alive being. It is a beast. Every year, it takes a deep sigh in autumn, and the whole thing rises up. And over the winter, it grows, and then in spring, takes a big breath in, and back it sinks. It is alive with life. It holds huge amount of insect population, and with the insects come the birds. But not only does it create this wonderful, living, blanketed being in the landscape, it looks after a lot of our water. The peatlands, particularly the blanket bogs, make up most of the headwaters to our major rivers. So our clean water starts in the bog. And if the bog isn't in control and can't govern its own waters, I'll give you there you go, that's a much nicer picture. Then what happens is a lot of the particulate and the material ends up in the water, and then the water turns orange, and then the water gets more and more orange as it goes and takes on more and more particulate and becomes more polluted. So they keep our waters clean. They are also incredibly essential in flood mitigation. So people often talk about bogs as being a sponge, and it's a terrible metaphor. They are not a sponge because they are actually solid with water. A healthy bog is completely and utterly saturated, and a healthy bog should always have surface water all over it. So it doesn't take in more water in a flood situation, but a healthy bog is made up of many, many, many different mosses and different shrubs, low-growing shrubs, and some sort of rushes and grasses. And they make a very intricate layer that slows down the water. So the essential thing about a bog is it stops flash flooding. If your bog isn't intact, and you see this all over Hebden Bridge, Todmorden, all these places where they flood, where the bogs are very degraded above ground, the water comes off in huge amounts very quickly because the plants aren't there to slow it down. But the main thing that most people are really interested in bogs about right now is that they store huge amounts of carbon. So peatlands worldwide make up 1/4 of our terrestrial carbon. There is more carbon stored in peatlands than there are growing above ground vegetation. So they are huge sinks of carbon. And they developed in the Holocene, in the northern hemisphere. So just as kind of Neolithic farming was getting going, bogs were beginning to grow. And it's kind of best to think of them akin as our air conditioning system. We had too much carbon in our atmosphere, they are a way to store it, and then because they hold onto the water, they're keeping our whole system cool. 80% of the bogs in the UK are degraded or destroyed. Currently, on a daily basis, they give out more carbon dioxide than all the cars on the road today. They are releasing carbon dioxide in such vast quantities, and one of the reasons they're releasing them is because they're degraded, and part of that problem is us, because we have been milling them for horticulture. It's not the whole picture. There's many reasons why bogs are degraded, but we certainly, as an industry, collectively, are responsible for part of that. But anyhow, The thing about a bog, and the thing about peat, is it's kind of a zombie material. So peat is partially decomposed material that then gets suspended in animation because it is in an acidic, wet environment that is low in oxygen. So it cannot further decompose. So once it starts building up, unlike all other terrestrial soil systems, it can only keep growing up and up and up, which is why you get this raised dome on raised bogs. And most of the Midlands, this is an island, the middle of Ireland is a kind of complex of these raised bogs. And one of the ways you work out how much peat you've got is to do something called peat probing. This is Doug and his kids and his mother-in-law, because everybody comes out to the bog when you ask to interview them. And they're doing something called peat probing. And what you do is, because peat is soft, you push in these rods, and you keep pushing them until you work out how deep it is. When you hit something hard, you've hit the mineral layer, and you're at the bottom, you're onto rock. This is an incredibly degraded bog in the Midlands in Ireland that Donnie and Doug are trying to restore. You can tell it's degraded instantly because it is dominated by heather and by the reindeer lichen, the white lichen. So it is pushing on to becoming a dry heathland. Heather is always part of bogs, but when the landscape becomes dominated by it, it means that they're drying out. And you start to see what kind of carbon store it is, because they are pulling, they've now taken this apart out of pulling it. So this bog, which was an intensely degraded bog, which had been milled both for fuel and, at certain points, for horticulture, still has 8 meters of peat. You start to see how much these things have grown across the landscape. Now, there's a rule of thumb that a near-natural or natural bog, so that's a healthy bog that is in control of its waters, can grow 1 millimeter a year. So when people talk about bogs being a sustainable source of everything, it's absolute bullshit. There is no truth to it whatsoever. So this millimeter a year is also a way to be able to measure how old a bog is. So if it's a millimeter a year and it's 8 meters old, then this bog, or this part of the bog that they're standing on, is 8,000 years old. The bog actually would have risen originally before it was extracted above their heads, because you can find in a raised bog the edge, and then you can kind of draw the dome back over. So it gives you a sense of how much has been lost. I mean, and this is in Ireland, and we all know that there's a lot of peat extraction, but we've done exactly the same to ours. So we've just extracted for slightly different reasons. This is Banai Brecon, so the Brecon Beacons in Wales. This is the blanket bog on top of there. This has been overgrazed. And this is, I mean, don't need to tell you that's not very healthy. This is back in Ireland, outside of Dublin, in the Wicklow Mountains. So you can start to see how the bog is degrading at the base, because you can see peat there, but also, again, this dominance of too much heather and seeing grey stems. So seeing this kind of mature growth in the heather is a sure sign that the whole thing has been degraded enough. And if you're a hill walker, you have surely seen this at some point. This is a peat hag. And what has happened is that the peat has become exposed through erosion, so it has washed away, and so you have a bare peat exposed side, and you can see the living layer growing over and then coming over. So wherever you have a hag, wherever you have bare peat, you have this huge source of carbon dioxide. Because the minute the peat is no longer in an anaerobic condition and is exposed to air, it starts decomposing and releasing all that carbon. So what has to happen is these hags have to be reprofiled, have a new layer of mosses put on top of them so that they can stop eroding in that way. One of the interesting, here's a bit more on the Pennine way. This is actually us. This is not sheep, this is football. This is too many hill walkers. Again, once the peat is exposed, it's super fragile, it becomes dusty, it gets washed away by the rain, and in the summer it often because it's a huge source of carbon, it burns if people go and light barbecues on top of it. And then the amazing thing about it is the barbecue is put out, everybody thinks it's fine, but because the peat there's meters and meters and meters of peat, it draws it down and then it burns underground. And so you sometimes don't even know it's burning, and then the following spring you'll just come and see this wisp of smoke, and the underground peat has been burning all winter long. It's kind of extraordinary to see. But one of the sad things, but one of the interesting things about all of this degradation and erosion is that you get to really see how the peat is made. And the peat is made up of two distinct layers. On the top you have the acrotelm, which is the living layer, and this is the growing oxygenated region. And then you sort of can start to see it. Actually, it's where all those cracks appear. You see it's very dark at the top, and then the lower layers as we're going through it is the catotelm. And at this point, the peat has completely compacted into a very dense form, which, when it's healthy, is full of water. And so there's no spaces whatsoever left. The water has nowhere to go, so it becomes completely stable. And that's how it is able to raise and rise up out of the landscape, because it's building on this basically mattress of dense peat. The only peat that you can use for horticulture is from the catotelm. So not only do you have to take off the living layer to get there, you are always using peat that is at least 1,000 years old and could be 8, 9, 10,000 years old. So you start to see you're taking a very old source of carbon and releasing it into the atmosphere. Even when it's a thin layer of, this is considered a very thin layer of peat, you can still see that top living layer, it's a much lighter brown, and then the dark, rich, fudge-like peat that makes up the kind of essence of this being, and then the mineral layer below. And because this is degraded peat, you can see the color of the water. Everybody goes up north and thinks all the rivers and streams are terribly romantic because they run orange, but they're only actually running orange because in the last 100 years we've degraded the peat bogs, and it's literally peat washing away. It may be nice to swim in, but not necessarily a good thing. Yeah, so here you can see, and you can also see what happens over time if the peat is exposed and these peat heads are exposed. So that light brown layer is the catotelm, so the really super old peat now being exposed to oxygen and starting to rot away. So the short answer is, if you see peat, it's not a good thing. So that's the sad, damaged side. Now let's go to the miraculous, wonderful, happy side of the bog, which is in the northern hemisphere, this entire system is governed by the smallest of plants. A bog, or in their technical terms, mires, are only growing and are successfully living if they are covered in sphagnum moss. The majority, like over 95% of peat, is dead sphagnum moss. So this tiny, tiny land plant, this bryophyte, which is that gap between the algae and when we were looking at Eddie's timeline, you had algae in the water and then you had angiosperms this way. The first plant to bridge that gap were the mosses. So it's this plant that is both water and land, and here it is doing all the ecosystem engineering. And for a single genus, sphagnum moss hold more carbon than any other plant in the world. So yes, the forests are hugely important. This is not to make a hierarchy, but the trees are a hugely important source of carbon, and the fungi is a hugely important source of carbon, but so is this tiny, tiny, sweet little moss. There are about 150 species worldwide. There are about 70 species across the UK. the very best place you can go is to the Flow country in the northeast corner of Scotland. You can find 36 species up there. If you come and see me in Aberystwyth, I can show you about 25. I actually thought this is going to be an easy one. I've only got to learn 70 species. Jesus. I used to have to do like plant things at Kew, which had 150 on them. Honestly, the most complicated things to talk about and learn the difference of, because you have to look down a microscope. So they come in these wonderful different colors. I thought you'd have a poem in case you're bored of hearing me. They change color, so they have seasonal colors. They have autumn colors and spring colors. They can be tight little hummocks, or they can be loosey-goosey types that live in hollows, or they can be flat species that create lawns. So the bog is not a flat system by any means. If you ever get onto a bog and you see this, these little, lovely little round bits on the bog, those are the spore capsules. And if you're on a bog, you should be in waterproofs, because if you're not, you're foolish. You get down and lie very carefully and put your head, and you can hear them audibly pop, because they have to open up and explode to get the spores into the upper atmosphere so they can move around the world. It's a really wonderful, trippy noise. You can also find sphagnum species that live in woods. So if it's a very damp woodland, you'll find versions that grow there, and they'll grow along stream sides. The most interesting thing about the sphagnum moss is at any given point it has to be as dead as it is alive. So it is always dying and growing at the same time. And unlike any other plant, death is how it moves. So all plants have to die to recycle themselves into the system so it can go on. But sphagnum moss actually has to be dying and growing at exactly the same time in order to be alive. And that is, I became completely obsessed with climos. I really love old science papers which were written in like the 60s and 70s, because they felt that they could put poetry back in their space. I don't think people do this anymore. And he'd write these very kind of, his work is still the kind of dominant work in sphagnum mosses, so you have to read a lot of his papers if you're going to try and get your head around it. And I felt like I was kind of walking in his footsteps around England, listening to him say Tennyson. But so this is in Roundstone Bog in Ireland, up in the northwest. And if you look across it, like everybody's like, oh, bogs are just really flat. But if you get your eye in, what you can see sort of in the middle here is a huge lawn of sphagnum species. So if you went and walked on that thinking, oh, that looks nice and flat, you'd sink up to here into your knees. And then in the you can just see across it these like little hummocks. So you have hummock species, you have pool species in hollows, and then you have these lawns. So you have this micro-topography, which is incredibly important to the health of the bog, but is also important in that flood mitigation, and it's also very important in how it captures carbon. One of the things about the hummock species is in the middle of them is they're always growing over a piece of heather. So when it's a healthy system, there are heathers dotted all around. And the heathers are always trying to grow up out, and the mosses are always growing faster than the heather can, so that all you get is this flush of brand new growth. And of course, this is fantastic, because this is what the grouse and all the birds feed on this young stuff. So a healthy one is naturally regenerating. The problem is, on many of our moors, what has happened is we've got into this cycle of burning them to get that new growth. And when you burn them, you lose the mosses. But if you just can leave the bog intact, it will naturally do this thing of the mosses are always out-competing everything else. So how does this tiny, tiny little plant, the very fastest any of the sphagnum species can grow is 10 centimeters in a year. But these hummock species will maybe maximum grow a centimeter a year. So how is a centimeter a year outgrowing the heather? Well, they're doing it. These are some of the loosey-goosey types that live in the water. There's more watery ones. Sorry, I'm never very good. They're doing it because of this thing of being more as dead as they are alive, in fact, more dead than they are alive. So when you, this was my very first iPhone microscope experience, so I had to clearly take a picture of it. When you get inside, you find that the architecture of the moss, because they do not have any roots, no roots whatsoever, so they don't have a vascular system, so they don't have stomata, so they don't control their water through that way. They control it through the architecture of their leaves, which are sort of cupola-shaped, like that, so around like that, so they capture lots of water down in these spaces and they channel it down. But then when you move in a bit closer, oh, that was my first tardigrade. I was super excited about that. Sent it to my mother-in-law. More climber, because I'm obsessed with them. So when you get into the next bit, oh, God. What you find is down at a cellular level, these aren't diseased cells, these ones which are wilting. These are, so the moss is made up of two kinds of cells. It has the green chlorophyll cells, which are doing the photosynthesis, and then the larger ones are dead hyaline cells. So these are balloon-like cells that are only achieve their fully functioning status when they are dead, and they expand to hold water, and then when there's no water, they shrink down, and the moss becomes white and pale and brittle and dries out. But then the minute you give it water, poof, it expands again. So famously, you can keep a bit of sphagnum moss in a jar in a cabinet for 50 years and then re-wet it, and bam! Within an hour, everything starts back to life again. And that is because these hylines, these dead cells, so there's one living cell to 20 dead ones, have an entire world inside them. So inside, so around each leaflet, and then inside each hyaline cell is a menagerie of microbes and creatures. So you have the big guys like that tardigrade, that's one of those water bears that people love to talk about around mosses. And you have rotifers, and you have testate amoebas, and then you have all different kinds of bacteria and protozoas. And many of them live around the moss, but many of them, particularly the bacteria, live inside. So this is a dead cell that has an incredibly complex relationship happening in it. So inside, what happens when you have an anaerobic, watery condition is that you end up having lots of methogens, which produce, instead of producing carbon dioxide, they produce methane, because that's how they're respiring. Too much methane is not good for the environment, but if you have a good system, which is what the sphagnum has, you have methanotropes. These take that methane and then convert it into carbon dioxide. They then give this carbon dioxide to cyanobacteria that then create carbon and photosynthesize inside this dead cell, and then they pass some of that stuff over to the chlorophyll cell. So we have this incredibly, I remember that Darwin and Linnaeus called these lower plants. Everybody has thought about the mosses as pretty basic, and yet inside this basic plant is this extraordinary world of energy happening. 20% of photosynthesis inside the moss that is doing more carbon capturing than any other plant in the world is done by bacteria living in a dead cell. It is like an impressive system. I tracked this one in just for Merlin. There's been a lot of interest recently in whether there are mutualistic relationships with fungi and sphagnum cells, and because sphagnum don't have any roots, there isn't any mycorrhizal relationships to have because there's no roots for them to get in, but it turns out they have a more basic fungal relationship. So if I understand this right, in the right slide up there, the little green dots are cyanobacteria, so these are bacteria that can photosynthesize, and then the white globules are a kind of fungi, and then as you go in closer, you can see that they are doing their own little joining up So there's a tripartite relationship between a bacteria, fungi, and the hyaline cell, which means that even more carbon is being captured. Now, one of the reasons that the mosses can capture and do all of this work is so that they stay ahead. And remember, we talked about this, these are rain-fed systems, so they do not have water coming through soil, so they are not taking in extra nutrients from around them. So the only place they are getting their nutrients is from the clouds, which have some nitrogen, but not a great deal. So how are the sphagnum moss outcompeting? They are doing this thing that a paper called it geochemical warfare. And I thought, I really don't agree with it. In fact, this is, I think, the lesson that we need to learn. What they're doing is they are exchanging, so they are a filter, and they take all the nitrogen and phosphate and nutrients from the rain before it hits the peat and the vascular plants. So they are a filter. And when they take in the nitrogen, because it's such a poor condition, they have to do this cation exchange to keep it. So they keep hold of all the nutrients inside them, and they release acid. The bog only stores carbon because it's a pickling system. The peat is not breaking down because it's essentially just the same way you would pickle cucumbers. It's an anaerobic, acidic system, so anything that's in it that can't rot. The reason it is staying acidic is because the mosses are keeping it so. So the moss is entirely control of the whole system. Now, you can call it geochemical warfare against the other plants because it steals all the nutrients, but the truth of the matter is, if it didn't do that, the vascular plants would outcompete them. And if you're a tiny little plant like this, what do you need? You need to be in the light all the time because you've only got a small space to photosynthesize. So if there are too many shrubs, you're going to be shaded out. And if you are shaded out, the bog stops holding onto its waters. And if the bog does not have sovereignty over its waters, it dries out. And if it dries out, it releases carbon. So yes, on the scheme of things, the bogs look like they're slightly being arseholes. They're very acidic. They are slightly, they have an acid nature. You can make all the metaphors you like out of it, but the reality is them stopping the big guys, the vascular guys, from robbing the system too much. Because a bog that is degraded, that has vascular plants growing into it, has roots that go down into that peat, and they expose that peat to oxygen, and then that peat starts rotting. So the last thing that you want on a blanket bog is too many vascular plants. So yes, the sphagnum looks like it's being an arsehole, but truly it's acting local to think global, because if these guys release all their carbon, our atmosphere is going to get super, super hot. So I guess my end moment for this is we are in a really critical moment as an industry around peat-free. There is no legislation which is binding from our government around being peat-free. They're still not pushing it through. So yes, many of us have moved over to not using peat, and that is fantastic. But until we do it as an entire industry, it doesn't really matter if just some of us do it. We all need to do it together. So we need to behave like the mosses. We need to think locally to act globally. Because one of the things about non-binding legislation, so that there isn't anything to really keep peat out of production currently, is that all the licenses for peat extraction in the UK are indefinite. So people will keep extracting from the 8 or so sites in England, from the 12 sites up in Scotland, and the numerous sites in Northern Ireland, until there is no peat left. And that is releasing so much carbon dioxide into our environment. But if we don't argue and demand and write and protest and do the whole thing that we need to do as an industry, what is going to happen is we are going to be flooded from peat from elsewhere. Because we are the leaders in peat-free horticulture, but it is not a global picture. And they are extracting still from Belarus, from Estonia. China has just gone into huge, huge extraction of its peat. There is going to be peat coming in everywhere. So we as an industry have to start working together. And that means stopping being, hey, I'm peat-free, and being, how do I help you be peat-free? We need to look at the tendering processes. We need to look at all the different nurseries. We need to care about the petunias, even if we don't grow them. Because right now, we're extracting peat to grow petunias, and that is stupid. So collectively, we need to work together. It cannot just be, oh, we're the good guys over here. We need to start talking about how we make the entire industry, all the show gardens, all the posh gardens, all the public gardens, all the petunias, all the, amenity, all of these spaces need to be peat-free, because this system is such a beautiful beast. If you spend time on them, you cannot but fall in love with how alive this being is, and it deserves personhood of its waters, and it deserves to remain and continue keep growing.
Well,